calculate CT values, and in particular, we're going to look at fold difference or fold increase. As you can see here, we're primarily looking at the effect of different concentrations of MCP1 or treatment on an ER stress gene called CHOP. A reference gene or housekeeping gene is GAPDH. Right here on the left, we have all our raw data. We have technical replicates. Nowhere in this experiment do we have any biological replicates. So this represents just one experiment. On the right, we begin to look and assess the average CT values for our technical replicates. As you can see here, I've cleaned up the table and narrowed it down so it includes not only the treatment groups, the labels of the types of genes that we're looking at, and the time points. In the first cell, where it says 0 hours at 0 nanomolars of MCP1, I have a formula that states equals average, and the selection is B4 through B6, which is basically these 3 data points. When I hit enter after typing in that formula, I get my calculated value. The nice thing about Excel is I can take this cell and I can grab it and move it left to right. And in doing so, these 3 cells now correspond to their actual data points. And I can check that by looking at and grabbing the C4, C6 value and seeing that it's collecting the right pieces of data. In order to extend this down and to bring this down all the way to the bottom, the only way I can do this is I have to calculate each point for right now, the starting points of the averages for each of these 3 technical replicates in this first column. So for this cell, I have to calculate the average for these. For the next cell, I have to calculate the average for these, and that moves down. However, once I have those values, I can again move left to right, and that should grab all values that are needed. And I can actually go all the way to the right for all cells, including the CHOP gene. Once that's done, this table is finished, and I can go and start calculating my first difference in CT values, or my first delta CT. To do this, I'm basically looking at the difference between the gene of interest and the housekeeping gene. So I'm looking at the difference in CT values between those two. So the change in difference is basically comparing the treatment level at the treatment time of the CHOP gene with its corresponding GAPDH or housekeeping gene. So to do this, I take this value right here, and I'll signify it by putting equals M4, or this value right here, and I subtract it from its corresponding housekeeping piece of data. Once you hit enter, I can then grab that left to right, and I can actually, once I do that, pull that all the way down, and all pieces of data should be intact. You can check that out again by just going up here to the top where it says FX and making sure that each of the boxes are relatable. That means this 0.1 nanomolars of MCP1 CHOP is lining up with the 0.1 nanomolars of MCP1 GAPDH at the same time point. So that calculates our first delta CT value. But we need a delta CT value, which means basically one of these values is our reference point. It's what we're going to compare everything to. And that's the absolute simplest control, and that's 0 level of treatment at 0 hours, which is going to be this box. So I'm actually going to highlight that box, so we can put that box right here, and that's going to be our reference gene, which means in the formula right here, what I end up doing is I say that this value, if you look carefully, escape this, if I click here, click on that spot, we're saying that this box is subtracting from its own box. Okay, so that should give a value of 0. It's important to note that when I type this out, because we're subtracting this reference gene, this ladder box right here, if you put the $ before the J value or before the letter value you have, and then before the numeric value, that locks that cell as your reference point, which means I can take this box left to right again and pull it all the way down to include all sections. And in doing so, all of these values are now subtracting out that one box. So if you see 11.2 is subtracted out from all the values, and you can double check that as you move through. So that gives me my delta delta CT values. For fold difference, we need negative delta delta CT, and so that's what we have calculated here. This is as simple as basically just telling this cell to be the negative value of whatever these calculations came to be. So the simplest way to do that is you literally put equals negative, and you go up here and you click on the cell that you want, your first cell, and hit enter. Again, you can drag left to right, and in doing so, that relates the same formula to all the cells and its corresponding data. And then I can drag this corner all the way down, and everything is now included. So now I have my negative delta delta CT. And if you recall, if we take 2 and raise it to this power of negative delta delta CT, then we actually get our calculated fold difference. For example, our reference gene, our single gene that we're looking at, our control gene, it's 2 to the 0th power, which is 1, which makes sense because that's what we're referring to. So anything over the value of 1 means our gene is induced, and anything under that value of 1 means our gene is suppressed or brought down. So it gives us a point of reference to see what is exactly happening. So here, what I have done is I have taken in the cell, I have put in the value of 2, so we put equals 2, and you can, right about the number 6, use that up arrow to put the up sign, put that up saying that we're going to superscript the value that we choose over here to the table to the left. When we hit enter, that gives us our calculations. And again, as we were doing before, we can move left to right. And then we can bring all these values down. And in doing so, now we have our fold difference. Well, we want to grab this and graph it. And we want to put it on a nice line graph. So what I'm going to do is, starting with this blank corner here, I'm going to go left to right and then pull all the way down to make sure I include all those pieces of data. I can then come up here into insert. I can look at my choice options for graphs, but I'm going to choose this line graph right here, and I'm going to choose the first box. And here we have a nice, beautiful line graph, which is sort of almost there, but not quite. If you notice, there are no axes labeled. You don't really have a proper title yet. We're going to go ahead and take care of the title right now. So we're going to primarily look at CHOP transcript level. That's the gene that we were interested in. We're going to move our table that tells us what each line represents. And we're going to add lines here to clean up and make this x-axis look a little nicer. So the way we do this is, and I'm using a Mac, PC will have a little bit of a different way of doing this. Usually it's a right-click option, or there'll be a plus option up to the top right corner. But in Macs, you can click the actual x-axis information. If you right-click on it or do a control-click for a Mac, you'll be able to then find what you need to do. You can put in information such as format chart area. That'll give you your whole area that you want to do. Over here, I'm particularly interested in the axes. So now it's asking me if I want to format my axes. When I do that, make sure it says format axes. I want a line. I want a solid line. It's black. And I also want to thicken it up so it's easier to see. Okay. So that's good. I don't close this box out. I actually just moved to so that was the y-axis. Now I'm going to do the x-axis. I just move over there and click that, and that keeps everything open and easy to find. Again, I'm going to choose a black font, and I'm going to use a 2-point value, weighted value, so it's easier to see. And it's all about your reader and what's easy for them to see. So one thing I want to do is I always like to bolden my terms, again, to make it easier for everybody to see. This is a little clustered to me. I don't think you need all these values in 10. So while I have my, if I click over here again and bring my axes options open, if you see it lets me set the boundaries. 80 is fine. But then the units is at 10. And I think putting units at 20 is going to clean this up just a little nicer. And you see it's not as condensed, and it makes it look a lot better. These faint lines I don't like. It just adds to it. So if I highlight those and delete, it gets rid of those as well. So really the only thing we have left to do is now to add the axes title. So I'm going to come up here and I'm going to click on my graph. If you look here, I have a chart design. You can also add a plus sign if you have a regular PC, and this is where you will find it. For me, it's going to be a chart element or add chart element here. I'm going to choose axis title. Primary horizontal will let me set my x-axis. So this is time after treatment. Again, that should be good. We can bolden that up. Space that out, and that looks beautiful. Now I need my y-axis. And so what I'm going to do again is go to my chart design, add chart element, and we're going to do a primary vertical. And this is going to be fold. We'll put relative fold change, and this is compared to control. And we're going to come here to home, bolden these terms. We should highlight it first, bolden, and our graph is now good to go. And so this is the final piece of data. This is what your graphs should look like when they're all cleaned up. And you tell me what it means. It seems pretty obvious what happens when you have a treatment and a particular treatment level over time, but you interpret what it means. You not only tell me what's happening with the treatment group, you tell me not only what is happening, but when it is happening.